Hello data managers, this is Mr. Dunbar speaking. So a few of you have asked for some additional guidance on the Gizmo activity. I am making a quick video to show you some of the things that go into the Gizmo and how to use it. Well, the way that the assignment works is it asks you a few prior knowledge questions and then provides you with a little bit of background. So in this case we've got the Gizmo warm-up, and it describes the difference between permutations and combinations. So permutations are arrangements of objects where the order matters, and then a combination is simply a collection of objects where the order doesn't matter. So looking at the warm-up activity, you'll notice that the first one asks you to check that the number of tiles in the box is 3 and that the letters are A, E, and I, and then to set the number of draws from the box to 3, and to make sure that is order important is set to yes, and then to ask us to simulate things 8 times and record the results below. So let's take a look at how that works. So we need to make sure that we have 3 tiles in the box, and that we do 3 draws from the box, and that we make sure that order is important. So now we're going to simulate 8 times. Now each time that you do a simulation, you'll notice that you have the letters E, A, and I in some form of permutation. So the first one gave us E, A, I. The second simulation gives us A, I, E. So you do that 8 times and record each of those efforts on your data sheet here in the 8 spots. And then continue doing that So then it also asks you to look at the tree tab on the right side of the Gizmo. So if we look at the Gizmo, there is this tree tab right in here. So we have the trees. We also have a list format, and there's also the official notation, which you would be writing, let's say when you're writing a test or writing an assignment or writing a report. When you're doing the activities, it's important that you read these boxes at the top, which give you the instructions. So here you're told the number of tiles to set, the number of draws, and whether the order is important. For this first assignment, the order will always be important. So let's look at question 1. Suppose a box contains the 2 tiles A and E, and you are going to draw 1 tile out of the box. So how many permutations are there of 1 draw from a box of 2 tiles? Well, it's either A or E, so in this case we have 2 possible permutations. So simulating that, we simulate 1 draw, we get an E. Simulate another draw, we get an A, and if we were to do it a few times, we'd get A, E, and so on. Next, we're going to be asked to increase the number of draws to 2. So what are the different permutations when you draw 2 tiles out of 2 tiles? So increasing the number of draws from the box, we have 2 tiles in the box and we're going to do 2 draws in a row from a box. And we'll notice in our tree the option is either AE or EA. So if we were to simulate that, you'd expect to see AE half of the time and EA half of the time. So if we kept doing that, we should end up with about 50-50. AE and EA are our answers, if you'll remember. So we also were asked to look at the tree tab, and if you pick A first, what is the only possibility for your second draw? So if we pick A first, the only possibility is E. And if you pick E first, the only possibility for the second draw would be A. So I just want to point out something about the draws. You'll notice here we've got 1 and 2. 1 and 2 correspond to the draws. So the very first draw out of this box of 2 tiles is number 1. The second draw is the second draw, obviously. So if you've got A and E in your box, your first draw could be either A or E, and then your second draw would be whatever wasn't picked the first time around. So the notion of first draw, second draw, third draw come up in subsequent sentences. So you'll notice here in question 2, we've got how many choices are there for the first draw. Once you pick the first tile, how many choices are there for the second draw? So in this case, we had 3 tiles in the box, and we're doing 2 draws. So we have 3 tiles in the box and 2 draws. And you've got 3 possibilities for the first draw, but as soon as you take one of the tiles for your first draw, so let's simulate our first pick and our second pick. So as soon as you got your first pick, I, you're limited to A and E for your second draw, and then you're limited to only A or E for your third draw. So how many choices were there for the first draw? 3. And how many choices were there for the second draw after the first draw? Only 2. And then you're asked about the number of permutations, so the number of unique ways of arranging these two tiles. And we can get that in 2 ways. We can first look at the tree and look at our terminal nodes. We've got 6 nodes. Or we can look at the list, and down here it very neatly summarizes everything for us. We've got 6 permutations. Now, how does the number of permutations relate to the number of choices? Well, it's going to be the product of the first draw, 3, times the product of the second draw, 2. So we've got a total of 6 possibilities in this case. So moving on to question 4 in activity A, which caused some of you some problems. We're going to change the number of tiles to 4, and we're going to keep the draws at 2. And we're asked how many choices are there for the first draw and how many choices are there for the second draw. Increasing the number of tiles in the box to 4, keeping the draws at 2, and keeping order important. So for the first draw, we have 4 possibilities, A, E, I, or O. And then for the second draw, we have only 3 possibilities. So we've got 4 for the first, 3 for the second. And then what does 4 arranged to equal? Well, in this case, it's going to be 4 multiplied by 3, which gives us 12. And this answer here preempts the question 4D. How do you calculate this result? Well, it's 4 times 3. So someone was asked about the challenge question, question number 8. In this case, what you're doing is you're creating the generic formula for a permutation. And you're using your observations from your simulations to do it. So I'll just finish off question 5 to add to our set of simulations so we've got various data points. Suppose there are 4 tiles and you're going to do 3 draws. So how many choices are there for the first, the second, and then the third tile? And then what does 4 arrange 3 equal? So I've got 4 tiles in the box. I'm going to do 3 draws, and I do care about the order. And in this case, I am asking how many possibilities are there for the first draw, the second draw, and the third draw. So in the first case, I've got 4 different possibilities, 3 different possibilities, and 2 different possibilities for each subsequent draw. So that's 4, 3, and 2. And if I look at the total number of permutations given to me, there are 24 in total. So when filling in my data, I have 4 choices for the first tile, 3 choices for the second, 2 choices for the third, and a total of 24 possible permutations. Now, going back up to our previous activity, we had 4 tiles. We took 2 draws out of the 4 tiles. So our first choice gave us 4, our second 3. So our first draw 4 choices, second draw 3 choices, and when we looked at the total number of permutations in this case, we ended up with 12. So we had 12 permutations. When we drew 2 draws, we had 24 permutations when we drew 3 draws. And that was for 4 tiles, by the way. Now going back to an earlier draw, when we had 3 tiles in the box, and we had 2 draws, there were 3 possibilities for the first draw, there were 2 possibilities for the second draw, and a total of 6 possibilities. So 3 times 2 is 6. So we multiplied the number of choices for the first draw by the number of choices for the second draw, and that gave us 2 draws. So with that in mind, now we're going to make the general formula. So suppose we're drawing a certain number of tiles from a box with a certain number of letters. Okay? And the order matters. So how many choices are there for the first tile? Well, we've noticed before that it's the same number as the number of tiles in the box. So if we have n tiles in the box, that means our first choice is going to give us n possibilities. Our first draw is going to give us n choices. Our second draw, our second tile, we'll note, we also might remember, is one less than the total number of possibilities. So if we have n tiles in total in the box to start with, the second draw is going to be giving us n minus 1 choices. And then so on, and then more like that for the subsequent draws. So a third tile would be n minus 2 choices. Now, here we've got the general format. How many choices are there for the rth tile? And it's asking you to be careful because there is a little, well, there's not much math. It's grade 6 math or grade 7 math. But anyway, there's a teeny little bit of algebra going on here. So now it behooves us to look at the pattern that's going on. The first tile is n. The second tile gives us n minus 1 choices. So, we've got a 2 here, but we're subtracting 1. So in this case, we're taking n, subtract 2 plus 1. Okay, we can do it that way. Here, let's take a look here. N minus 2 gives us the number of choices for the third tile, so we've got n, subtract 3 for the third, plus 1. So I think we can extend this to the rth tile. So in this case, we would, in all likelihood, have n tiles, subtract r tiles, plus 1. And that is our general format. So now let's write our expression for this. So n arrange r. Well, we are going to start with n, and then we're going to multiply it by n minus 1, and in turn multiply that by n minus 2, and we're going to continue on with this multiplication series by finishing off with n subtract r plus 1. So this is our general expression for n arrange r. So that's it for the gizmo. I will try to turn the answers to the worksheet into a quiz so that you can automatically check your answers. If you have questions, do post them in the classroom discussion forum, and I will try to answer them as soon as possible.